Hello friends, get back to learn physics now. Since we have already learned what is electric field and electric potential, today let us find out what is the relation between those two things. So today we are going to learn relation between electric field E and electric potential V, or let me write it as write it as E and V itself. So we are going to talk a little bit about vectors today. Alright. Now what should I define first? Let's say that there is some electric field in that direction. Let's say this is E, the direction of E. Okay. Now if I place a charge Q naught, which is unit positive test charge, where do you think is the force it experiences? What is the direction of force it experiences? What do you think it is? It is in the direction of electric field. Since this is a plus charge, positive charge, it experiences a force in the direction of electric field, right? So it experiences a force here. Let's say that this is at a point A. Okay. Now my question is, what's the work that I have to do to move it from this point to another point, let's say, which is B? Okay. To understand that, we have to define two things. One is the direction of R that you are taking. Let me define the direction of R to be in the direction of electric field. So the direction of R is like this. Okay. Second thing is, I have to know what are the potentials at A as well as B. Let's say potential at A is V. Okay, potential at A is V. What do you think the potential should be at B? Should it be more than V or less than V? It should be more than V. So let me think that V plus dV is the potential at this point. Okay. Now what is dV? It's a small fraction of V. Whenever I say dV or any, for that matter, anything, let's say if x is a quantity, then when I say dx, it is a small fraction of that quantity x. Okay, and it's true everywhere unless specifically if I say otherwise. Okay, so the direction of R that I have chosen is that way, like towards my right, and the potential is increasing in the opposite direction. Now tell me, what is the work that you have to do to bring Q naught from A to B? You have already learned that, right? That work done, you had before told me that it is WAB, right, which is equal to some force that you are applying, the vector of it, dot dr. Correct? Now, since R and F, in which direction you are applying force? In this direction. Where is R? Like this. So, what is the angle between F and R? It is 180 degrees. So, I can write it as F dr cos pi is minus 1. So, minus F into dr. So, the work done is WAB minus F into dr. Clear? Okay. Now, this time, since we are using dV over here, instead of writing WAB, I like to write it as dW, which is equal to minus FdR. Alright. Now the problem is, what is this force? How much of force I have to apply? Now when I leave this Q naught alone, what direction will it move, or what is the force it will be experiencing? That force F will be equal to Q naught into the electric field. Right? Now you can apply this F equals Q naught into E over here, that is minus Q naught into E dr. This is dW. What are we supposed to find out? I have to find out what is the relation between E and dW, right? E and V, correct? So somehow I have to change this expression to bring in V somewhere. Okay, since you already know dW divided by Q naught, it gives you what? dW divided by Q naught is nothing but dV. So I can write this as dv is equal to minus e dr. Okay, now there are two things I can do over here. Either I can take integral and I can solve the problem, or what I can do is I can take e is equal to minus dv by dr. Alright, so this is the relation between e and v. Now this is the magnitude of it. How should I write in vector terms? If you have understood this, let me clear this part of the board. Okay. Now, how do I write it in vector terms? E is equal to Ex into I cap plus Ey into J cap plus Ez into K cap. So, E is, instead of E, I will be writing Ex, which is equal to minus dv by dx. Also, Ey is minus dv by dy and Ez is minus dv by dz. I hope it is clear to you, right? Now, what can I talk about this? dv by dr is the rate of change of potential with distance. dv by dr is the rate of change of potential with distance, correct? And it is also called as potential gradient or steepness. This is potential gradient. This is potential gradient. Don't you think it looks like a slope? So it is also called as steepness. It is a vector quantity, since I have told you. See, it's like this. It's a vector quantity. And in which direction it will be pointing to? It will be pointing to in the direction of decreasing potential. Okay, so it will be pointing in the direction of decreasing potential. I had drawn that figure, no? From here to here, this was point A, this was point B. Potential was V here. Here the potential was V plus dV, correct? So in which direction will be E? E will be in the direction of decreasing potential. Potential is more here, here it is less. So the direction of E is in the decreasing potential. That is why this minus is there over here. Is that clear? Okay. Now, how will be the question which is related to this? Say, for example, I hope I can clear this. You have understood all this. Okay. So the question will be something like this. They'll give you the expression for V. So let us say they have given you something like the electric potential V. The electric potential V at any point x, y, z, which is given in meters in space, is given by, suppose V is given by 4x square volt. Okay. Calculate the electric field at a point 1, 0, 2 meters. 1, 0, 2 meters. Okay. At, you have to find out E at, okay. You will have to find out what is E at 1, 0, 2. Okay. So, you'll have to find out, your question is E at a point 1, 0, 2. How will you do this? So, what is given? Given is V is 4x square. They have given you this. Okay. And what all do you have to find out? You will have to find out E, right? What is E? E is Ex I cap plus Ey j cap plus Ez k cap. So if you can find out what is Ex, Ey and Ez, your job is done. Correct? So what is Ex? It is equal to minus dv by dx So this is equal to minus d by dx of what is v? 4x square. Correct? So this will be minus 8x. Differentiation of 4x square is minus 8x. That is 4 is a constant. Keep it outside. Differentiation of x square is 2x. So 4 into 2 is 8. Minus is there. So minus 8x. Right? Now what is Ey? It is minus dv by dy. Since there is no y term in v, this will be equal to 0. Similarly, since there is no z term in v, Ez is also equal to 0. Done? Now, if you substitute this value Ex in this, you will get E is equal to minus 8xi cap. Okay, but your job is to find out what is E at this point, correct? So wherever there is x, you have to substitute 1. Wherever there is y, you will have to substitute 0. Wherever it is z, you will have to substitute 2. Since there is no y and z terms over here, you will have to substitute for only x, right? So E finally is minus 8x into I cap, which is minus 8 into 1 into I cap. That is, E is minus 8 I cap volt per meter. What is the value? What is the SI unit of E? You can talk about that also. See, E is equal to okay. E is equal to minus dV by dr, right? So change in potential is volt, R is meter, so volt per meter. So the SI unit of this is volt per meter. So the final answer is E is equal to minus 8 I cap volt per meter. So I hope you understood this problem. If you have any doubts, or if you want me to discuss something more in detail, please do comment and like this video. Thank you.